Pause it for this week. We are going to be basically finishing the notes from last class and doing our introduction to circles. So this is the beginning of Unit 2 already. Can you believe it? Unit 1 is mostly done in the live instruction. I know you guys have some lessons left in the OMHS because we are a little bit ahead, which is how we want to be for sure. I'm happy about that because we're going to have things come up, like we have the Martin Luther King holiday coming up. And so it's good to just kind of be a little bit ahead. So what is a circle? I know you guys have seen circles and you've worked with them, you know what they are certainly, but the geometric definition of a circle is a shape with curved edges It's also a collection of points. I should have just typed this. A collection of points equidistant from a common point. And oftentimes we call actually all the time, we call the common point, in this case, the center. You see, here C is the center, and it's a collection of all these points all around the edge that are all the same distance away from C, everywhere you go. This distance actually has a special name. Here it is. It's the radius. The distance from the center to any edge is the radius. And it's funny that we call it an edge because I feel like when I think of edge, I think of like a straight edge. But here we're talking about the curved edge of the circle. There's really no special definition for center. Here we'll just tell us that it's point C. It's right in the middle. It's kind of the inverse of what a circle is, right? It's the point that's in the center of a shape whose collection is equidistant away from the edge. And then, of course, we have the diameter. The diameter is from edge to edge through the center. It has to go through the center. So it goes from edge to edge, but it must go through the center because we're going to see some other things that go from edge to edge, say like this. That's not the diameter. This is something else. It does not go through the center. We are going to go over this, but this is called a chord. So the diameter has a special definition that it must go through the center. So we're going to talk a little bit about circumference and area today, and I just wanted to show you guys some images on how we use circumference in our world, certainly like the distance or length around the basketball hoop, around a pie dish, the circumference around the globe. So the circumference formula is on your formula sheet. Don't forget you're allowed to use any time in this class and on your SOL on any assessment. I'll put it up here. Circumference is 2 times pi times r. In the problem, it will usually tell you, it might say something like use 3.14 for pi. Remember, pi is just a number. It's 3.14159. That's all I memorized. And then a bunch more digits. It literally goes on forever. So we have a symbol for it. And you have a pi button on your calculator. But also, sometimes, again, the problems will say just use this approximation for pi. So make sure you're reading those questions carefully. So let's figure out the circumference of the circle. When we're doing formula problems, it kind of might feel a little boring because you're kind of just plugging it in, right? The radius is 12, so it's going to be 2 times pi times 12, which is, so 2 times 12 is 24 pi inches. And I'm going to leave it like this for a moment because even sometimes you will see questions left in this form where they don't even multiply the pi out. If you're like in a multiple choice question, you might see the pi left in the problem. Let's try this one. 2 times pi times 14. So we're going to have 28 pi. So I'm going to go to my Desmos graphing calculator and type 24 pi and see what I get. All right, let's come up here. You can type 24, and here's the pi button. I think also you can just type the word pi. Yep. So that's so funny because I'm on the keyboard and I typed pi and it turned it into pi. That's great. So 75.4 inches is the circumference. All right, let's do 28 pi. I'm just going to type pi. So that's going to be 88. Let me get back. Kilometers. All right, it tells us we have a circle and CR is 3 centimeters. What is the length of PQ? So CR is from the center to the edge, right? That's a radius. We can have infinitely many radii in a circle, right? So that there's one, there's one, there's one, there's one. Oh, here's one, that's 3. These are all 3. Here's one, that's 3. Also, we know PQ goes right through the center. So what is PQ? PQ is the diameter. The diameter is always 2 times the radius. It's double. Because see here we have the radius of 3 and the radius of 3. So the whole thing is 6. That's it. Oh, I guess the units are given, they're centimeters. All right. Now we're going to talk about area. So area is coverage, right? Like how much mulch do we need to cover this circle? How much sauce or how much cheese do you need? This is a pretty famous problem, not this one specifically, but trying to determine which pizzas are going to give you the best like value for your money. We should talk about this one day. How much, so here I guess we would talk about volume, but let's say you wanted to, let's say there was like a marine animal in here, or a few, and you wanted to cast a net that covered this whole space. What would the area of that net need to be? So with area, we're talking about coverage. And the area of a circle is pi r squared. Remember, squared needs to write it twice. So this is pi times r times r. So we're going to have, here they tell us the radius is 12. These are the same circles, but I just wanted you to see how to find the area. Pi times 12 squared. So 144 pi inches squared. Remember, area is always in units squared because you're taking 12 inches times 12 inches, right? And inches times inches gets you inches squared. And here we're going to have pi times 14 squared. Let's go to the calculator. So 12 squared times pi. 12, you can hit this little key, times pi. That's huge. And then 14 squared times pi. So 452.4 inches, inches squared, and 615.8 kilometers squared. Okay, that's it, you guys. I hope that you found that to be pretty straightforward. While I have you, let's do just a quick view of your OMHS. All right, here is our calendar view, our plan view, which you could always get to. You could go to our course and click plan. And let's see, here we are today. So today's lesson on your own was 1.8 triangle similarity and Pythagorean theorem, which of course we've already done both in live class and the PlayPosit. And then you'll have your Unit 1 test due by Friday. Looking ahead, next Monday is a holiday, Martin Luther King Day. And then you start Unit 2, and you'll be covering circumference and area. which we just did in that play posit. And then next live class, we will be doing composite figures and basically all of these volume formulas. It's a lot of formula work. Ideally, you guys are going to think this is pretty straightforward, pretty simple. If it's not, that's totally fine as well. We can work through it. But we're going to be covering basically all of these units in our live class on Wednesday and our play posit on Friday. So you'll be, again, ahead. And then you'll take your test. And then we get further into circles with Unit 3, heading into February. And then finally, we will get in, so Unit 3 is all about more circle stuff. And then Unit 4, which is the end of February, is our trigonometry unit. So we're going to be learning about sine and cosine, tangent. Those 3 trig functions are the ones we're going to focus on this year, and that's your last unit. So by the beginning of, second week of March, we're literally done with the content for the year, and we're going to spend the rest of March reviewing for your exam, and then finally the month of April, we will be reviewing for your SOL. So I planned this out specifically so we would have the entire month of April to review. And then when you head into May, there's obviously nothing on the plan quite yet because you guys will be doing your SOL test in the month of May. So I know it's only January, but the road ahead is looking fairly clear, you guys. It's kind of like we're almost there, so keep up the great work. And I will see you next Wednesday. Reach out if you need anything.